Welcome, Wes.
Hey there.
Welcome.
Good morning. Thanks for having me. Can you hear me okay? Is the audio good?
Yes, the audio is all good. Yeah. So we're on
Beautiful.
to you. Do you have
Thank you.
some slides that you want to share soon?
Yes, I'm going to go ahead and share a page. Let me share that on the presentation. Actually, it'll just be my desktop mostly. Let me share this first. We'll go through some source code, and then I'll share my fuller desktop for a quick demo of Hello World, if that works.
Okay. Thank you. I'll add it to the stage. Yes. Okay.
Excellent.
All right.
Well, thanks everyone for joining in and letting me give you guys an overview. To give you a little bit of background, my name's Wes. I'm a DevRel person at Eigenlayer. And prior to that, I was building a lot of off-chain Web3 systems at Protocol Labs. And so I've been really having a lot of fun the past year helping folks design AVSs and think through their architecture. And so this Hello World AVS is a very good starting point when you're ready to build your AVS. I mean, particular, like, for the purposes of this hackathon, it's really complementary to the wizard that you'll build in alt layer to build your AVS. And I think that the Hello World example builds on top of this. So we'll kind of go into some underlying detail about how the AVS works, what works well about it, and how you might want to evolve it over time as you move into testnet and mainnet.
Awesome.
And so, yep. So we'll go into just kind of briefly walking through a little bit of the architecture, and then I want to take you guys to the source code as well of the AVS. And so this is the most simple AVS we could possibly come up with. It is a service over here that's going to automatically send a request to the AVS contract, and it's going to say, here's a string of text, a randomly generated string of text. And for the operators, all I want you to do is accept that string of text on chain, add the word hello to it. So hello, whatever the random string of text is, and then write that back into the contract. So just acknowledge that you're getting the message, append a string. That's really the only off-chain computation that we're doing is we're appending a string to it, and then write that back on chain. And that will be the end-to-end flow for our AVS. In reality, you'll extend this off-chain behavior to do much more complicated, sophisticated things once it receives notifications and tasks on-chain. But this is the simplest one we wanted to build out. And as you get into the source code here for your Hello World Service Manager, which is sort of the root of your AVS as a contract, you'll see that it makes calls into the Eigenlayer middleware libraries and the Eigenlayer core contracts as it's getting set up. But all the deployment and all the local testing is done for you in this repo. So you can at least get a really nice local test running on Anvil using this example workflow. All right. So before we go back into the demo, I want to give you guys a walkthrough of the source code and just kind of help orient you a little bit on how this repo is laid out. A couple of the most important ones here are contracts, where all the on-chain work happens, and operator. This is where all the off-chain work happens. These are kind of the two main components here. All of the AVS contracts will live on our contracts, as well as the testing for them and the scripting and deployment of those contracts. All of the off-chain code, in this case written in TypeScript, will live under operators. We've got some convenience utilities here and also ABIs. And for anyone that might be new to smart contract development, that is the contract definition interface that we'll use so that the off-chain code, when it's communicating with your AVS contract, it will use those ABIs to read it. And you can see if you actually blow this up and take a look at it, it's mostly just JSON files that describe the on-chain contracts. But it's important to have good alignment between those two so that the off-chain code can read properly. All right, so let's jump into the contracts folder here. This is going to be very standard for anyone who's worked with Foundry. Foundry is a very popular smart contract development platform and set of libraries. And this is kind of very standard here. We just forked off the standard Foundry template. We've got a few different folders here. Lib, which is going to include a reference to Eigenlayer middleware. Eigenlayer middleware is a repo that Eigenlayer produces. And it's really the building blocks for AVSs. So a lot of the interfaces for your AVS contracts live here. There's also embedded libraries that point to the EigenLayer core contract within EigenLayer middleware. So you'll see in the contracts that we build a lot of references to these libraries, and that's where they live. Also, the standard Forge libraries so that we can do deployments there. After lib, we have script. This is where we do all the deployment of the contract. So there's kind of two main components. One is just, if you're going to set up a local Anvil deployment, you do need to deploy the EigenLayer contracts because your Anvil network will be bare or won't have anything. So we'll set this up. This will deploy all the standard EigenLayer core contract for staking, operations, quorums for your AVS, all that gets set up there. And then the more interesting one here for your AVS is under Hello World Deployer. This will actually do the deployment, the setup and deployment of your specific AVS contract here. In this case, there's a lot of automation. If you go to these utilities here, we wrap a lot of the heavy lifting of the deployments under these util contracts, because one important thing that we do in these contracts is we leverage the Open Zeppelin upgradable framework here. So you'll see like Open Zeppelin transparent upgradable, Open Zeppelin proxy admin. And this is so that when you deploy your contracts to testnet or mainnet, you'll be able to upgrade those contracts as needed. This is more or less a best practice, especially early on in your AVS development. Some people may choose they do not want upgradable contracts, which is perfectly fine. But we do provide it here is especially from a development perspective, as you're making adjustments and you want to adjust parameters to your AVS, you might want to make it upgradable. So what that means is there's a lot of additional work here in the process of deploying the AVS. You have to use upgrade proxy lib, upgrade a call, deploy it. So we just tried to abstract that as much as possible in the utils folder here. And you're welcome to go through it in more detail, but I want to just give you some triangulation. This is where the core lives. Now, I will say the more interesting components here are under the Hello World Service Manager source repo. This is where the business logic is going to live for your AVS. One of the mental models that we use for an AVS is around the concept of a task. And in fact, even when this AVS is sending a request to Hello World to concatenate hello plus this random string, it's doing it in the context of a task. So what will happen is let me go back to our visual here for this architecture. When this consumer says, hey, I want you to generate a string that's hello world random string, it will actually be creating a task in this service manager here. And so this create task function right here that takes in a random string as the name that it wants to print out to. It creates this, this is a task object on the contract itself. And those operators over here will be listening for that task to be created. Tasks are not required for your AVS. There's actually very few firm requirements for your AVS. Particularly, the only thing you need to have on-chain is some event that could be slashable in the future, some evidence on-chain that can be agreed upon by multiple parties. But we do use this task model often because it's easy to kind of isolate a unit of work. So you're welcome to reuse that or adjust it as much as you need to. So here we're creating a task, and then the operator over here will fulfill the task. And when they're done fulfilling the task, they will write back on-chain evidence or result of their task, and they will call this function right here, which is response to task. And this just helps us organize. There is a specific ID for this task. There's a result set. In fact, it's a struct here, I think. Let me see if we have it defined in Hello World. Here we go. Task. Okay, it's a very simple struct with a name and the block that it was created. So that's really the only business logic here. As you're going to do more sophisticated things and you might have different types of tasks and you might have more complicated tasks on chain, this is the place to make those adjustments. Also, one interesting caveat for AVS development that might be a little bit different than some other development you've done in the past. writing good test functions for your AVS is very helpful because any business logic that you adjust in the AVS, when you go to test this end to end, when you go to finally deploy and test your off-chain code and your on-chain code, there will be a significant amount of, well, there'll be more complexity because you'll have off-chain systems you're trying to keep track of and debug on-chain systems. So the more time you can spend writing good test cases here for that logic and validate that everything works as well as it can, that hopefully will save you a lot of time in development there. Okay, so that's the contracts folder. Let's jump into the operator code. We have a couple components here. We have the Rust operator here. The Rust operator is currently underdeveloped. It's a bit on the back burner right now for our development team, partly because we're investing more of our time from a Rust development perspective in a different example AVS. Just for references here, if you go to Incredible Squaring, this is a different AVS, and I believe we're going to be having, I don't know if we have it referenced yet, but we're going to have an Incredible Squaring Rust example as well. So the Rust, I just called this out, this Rust code is a bit older. However, the TypeScript code is much more fresh, and it's getting a lot of updates, both now and in the near future. And this is meant to be the most simple, the most broadly applicable code we could think of. So many people can write in TypeScript and JavaScript. So we wanted to create this one as just an initial easy one for folks to use. This index.ts file is going to do a lot of things. It's going to register an example operator for you when you start it automatically. It's going to then listen for new tasks. And once it hears a new task, it's going to sign that task. It's going to create a message that's going to basically do the off-chain computation, which is hello plus whatever random name was generated. And then it's going to sign that message, and it's going to write that back on chain. This is calling our function on chain, respond to task. And that's really going to be the end-to-end flow for the operator. For the consumer over here, we have this create new tasks JavaScript file, which actually I should probably make a reminder to do just create new task. We'll call that consumer in the future. But this create new task here is going to basically just spam new names. It's going to pick an adjective and a noun, and it's going to send new tasks into the AVS so that we can get the end-to-end flow going. Just as sort of an example consumer. And that's pretty much all that's going to happen there. We have a nice write-up here of if I go back to the README, we have a nice write-up of how to test this locally. And I'm going to test this here for you guys in just a second. Start the Anvil chain, deploy the contract, start the operator, create hello world tasks. Also, I want to give a brief caveat here that in case you do run into issues, you've got a lot of places for support. We've got the Telegram channel right now for the alt layer, eigenlayer hackathon. Please reach out to us there. We've also got a support channel here. In the future, if you need additional support, you can raise concerns there. And then we also have some steps here to help you further debug your own local code here, enabling additional debug strings. All right, so that's kind of the high-level walkthrough of the Hello World repo. For next steps, I would love to pull up a terminal here and walk you guys through a demo. Let me just pause real quick and Han just ask, is it okay if I share my full screen with everybody? I will try to do that right now.
Yes, see if it works. Definitely it's fine.
Okay, perfect. All right, I am going to try my best to share in real time and run this demo to these steps. So what we've got here is I'm at a terminal here. I've got 3 terminal windows set up for the purposes of the demo. And let me go back to the README here. Let's go there. Okay, great. So the first thing I'm going to do is I'm just going to run node npm install. Actually, before the first thing I do, I will call out there are a few dependencies, so please take time to just walk through these dependencies to make sure you have these available on your machine. I'm testing on a Mac, but you should have good success with any Linux machine. Run npm install to make sure all the node packages are available. And then I'm going to run npm run start Anvil. So I'm going to run this here. This is just going to start a very vanilla Anvil chain. It's really nothing special, but it's a nice window just to make sure each time a contract transaction is invoked on chain, it's going to give us a new line and a new reference to the new block that's been created. So it's just in a good additional debug point to have open. Okay, separately in my new window here, I'm going to set up some environment variables. So I'm just going to, for the purposes of today, I'm just going to copy and paste to make sure we get these .env files set up. Those are going to point my operator to the local RPC environment, which is the Anvil chain. And then we're going to run a build command. This is going to go into all of the contracts folder here, and it's going to build everything. In this case, I didn't make any changes to the contract, so it's pretty quick. Otherwise, it might take 15, 20 seconds to build. And so this is stepping through each component here. Right now, our Anvil chain does not have any eigenlayer contracts. It's entirely vanilla. So we do have to deploy all the staking core eigenlayer contracts. Now we have those contracts on chain. And you can see here there's a bunch of transactions and blocks that were written in my local Anvil chain. Now we're going to deploy my hello world contracts there as well. So those exist. You can also extract the ABIs. If you made changes to your source code, you will want to run this command again because it will extract the ABIs again so that you have accurate contract mappings between the operator and the on-chain code. And then lastly, we will start the operator. This is going to start up our local TypeScript server. It's going to register a single operator to run against those contracts. So the operator first has to register the eigenlayer, then it opts into the AVS specifically, and now it's just simply waiting. We use ethers.js as the library to just listen for any events on chain, and particularly a new task event. And then in a third window, we are going to start that create task program. We're going to start this create new task program here by running a script npm run start traffic. Okay, let's go here. All right, npm run start traffic. Okay, so now it's going to create some sample names, create a new task with the name Sleepy Fox. And we want the operator to respond with Sleepy Fox. So operator says, new task detected, hello, Sleepy Fox. It wrote that back on chain. And we have our end-to-end flow. It detected a task, it responded to the task, we're good to go. In the near term for our contracts here, we're going to be upgrading these to add rewards payments because there's a couple additional features that, just as an FYI, are not fully in there yet. There's an integrate rewards PR here that's going to be coming soon. There's some substantial improvements to the repo itself that are coming up, like just basically making the scripts a little bit more user-friendly for developers. And then we also have slashing coming up later this year, which is a big component of the eigenlayer protocol. Slashing will enable you to basically disincentivize operators from malicious behaviors. So that's a caveat of a couple things going on there. Also, if you would like to follow the Hello World repo, particularly the releases, and get notifications, turn on watching there for GitHub. That's a great way to stay up to date to any updates and releases that we push along the way. So anyways, hopefully this was helpful just to give you some context. And I think you can see even more so now why the alt layer, wizard as a service, AVS as a service is so valuable because it can abstract away a lot of this complexity. But hopefully this is helpful for you to see the complexity, to kind of know what's going on under the hood, and be more effective building your AVS on alt layer. So Han, that's all I have for right now. I can pause if there's questions, or if not, we can break.
Yeah, thanks, Wes, for the great presentation. Question, just to kick off this process. As you can see, like right now, the task that you're doing is all on chain. And what do you propose people to build? Is it all fully on chain services like this, or is there things that you want people to build off chain and do it in passive, like a optimistic mode?
Yeah, that's a great question. I would encourage folks to build as wide and broadly as possible, including what you just described. Optimistic mode is fantastic, especially for early stage projects. Um, you're right. This activity is primarily on chain. There's a lot of folks that will do off chain computation, but maybe write like a ZK proof or some evidence back on chain. There's also different AVSs that the tasks are initiated off chain, and then eventually the result is written back on chain. EigenDA is an example of this, where the layer 2 that interacts with EigenDA will write to the operators a copy of its blob, and then only eventually does the evidence of that blob get written back on chain, the BLS aggregate key. So there's a ton of flexibility. The only thing that would be good to consider is at some point, as an AVS builder, the people that are going to use my AVS, the consumers of that AVS, they would like to have some degree of verification. Maybe it's optimistic verification, doesn't need to be immediate. At some point, they can have some level of verification of how it's behaving, both for the community's perspective and also eventually to enable slashing. So you have some conditions that are sort of, you could arbitrate on chain. But in terms of other than that, it's very flexible. So I would say, yeah, whatever is best for your end users as an AVS, most valuable for your users, is the way to go.
Yeah, definitely. That's very helpful. Yeah, for example, for us in our layer, we did it in the optimistic mode because for our client side, who are the one who we are deploying the AVS for, wouldn't want to do every single transaction on chain. So whenever we detect any fraud that happens, then we do it on chain as a reporting tool.
Oh, I love that. That's great, especially saving gas costs. That's brilliant. Yeah, that's so key.
Okay, right. I think that is mostly it. If there's no other questions from the audience, then I think we'll wrap it up as well. Thank you a lot for your time, and hope everyone had a good time just diving into the Hello World AVS and learning more about the EigenLayer and all layers ecosystems. Thank you so much.
Take care.
Thank you.